Today is Jeff Opel, the Southeast Regional Sales Manager at Filtrexx International, and today he'll be covering the topic of using organics for coastal resiliency. Jeff has 30 years of experience in the natural resources industry. Many of those years were served as district manager of several soil conservation districts in Maryland. As district manager, Jeff was responsible for advancing new and innovative sediment and erosion control technology used during the construction process. Jeff also administered the state of Maryland's Living Shoreline program in several counties in the state and participated in the development of several stream restoration projects. He used new advanced technologies, including the use of flocculating agents, to increase the efficiency of existing sediment control techniques. Jeff also created designs for multi-chamber sediment basins, incorporating biofilters to increase trapping efficiency. It was at this position that Jeff became familiar with Filtrexx, which was used with great success. Since leaving the government service after 20 years, Jeff ran a field office for a civil engineering firm in Delaware, as well as several landscape companies before coming to Filtrexx. With Filtrexx, Jeff has worked in business development for the Mid-Atlantic and in technical sales support for the Southeast region. Presently, Jeff represents Filtrexx as the Southeast Regional Sales Manager, and he's actively developing Filtrexx initiatives related to stream restoration and living shorelines. With that, I welcome Jeff Opel, and I'll turn it over to you, Jeff.
All righty. Good morning, everybody. First of all, I want to thank each and every one of you for taking some time out of your valuable day. Much like you, it seems like there's not enough hours in the day to get all the work done. Today, I'm going to talk about the use of organics as part of a coastal resiliency plan. And for those of you that aren't familiar with Filtrexx, and for those that you are, really, Filtrexx is an innovator in the use of organics in sediment erosion control and post-construction, both stormwater pollution control and living wall systems. And really what our founder, Rod Tyler, was able to do was to harness the value of organics and create a system or a technique or a process for us to harness those properties in a way that can be very adaptable to many different landscape solutions. We're mostly known for Filtrexx, which is in most states and in the entire Southeast United States is an accepted replacement for silt fence. It's a very high performing product. And I encourage you, if you're not familiar with it, to explore that a little bit. But one of the things that really attracted me to Filtrexx when I met Rod, I guess about 15 years ago when I was a regulator up in Maryland, was that they were not just and we are not just a product sales. You know, we've got bits, parts, and pieces that we sell. But what's really exciting about Filtrexx from its very beginning is we're a solution-based organization. Because of the kind of the simplicity really of these compost filter tubes that have different types of media in it, we're able to adapt them to many different places in the landscape. So what I want to do today, although we can't get into great depth, and I don't really want this to be a sales oriented call, I really want to talk about some of the areas in the industry that we've found ourselves working in, and we've really found ourselves working in it because of you guys, the engineers and the regulatory community who have looked at our products and have come up with new and novel ways of utilizing it. So I traditionally like these presentations to be very organic, so to speak, in that please feel free to ask a question at any time, because I really want to stimulate discussion and ideas. So we're going to kind of talk a little bit about coastal resiliency, about what coastal resiliency is. It's a term that we've really started hearing, you know, in the last couple years, and it's a concept that I think is useful for all of us that live in coastal environments and anywhere where water and land touch base. So we're going to talk a little bit about coastal resiliency. We're going to talk about the watershed approach. Filtrexx really looks at the landscape of not just interfaces between a construction site and undisturbed area. We really try to look at the watershed as a whole and how can organics be utilized throughout that whole watershed approach. We're going to look at some of our design tools. We're going to go into some projects really quick and some concepts that we have that we would like to put out there. And we're more than happy and willing to work with those people that feel that some of these concepts may have some application where you are. So I'll kind of wrap that up at the end. So really, what is coastal resiliency? Well, you got to define what the coastline is. And I started looking at some of those statistics, and as you can see, we've got over 12,000 miles of coastline. That's sheer coastline. You look at total shoreline, 88,000 miles. And you see this breakdown about the East Coast. What I found very interesting and never thought about it was the West Coast, the tremendous amount of coastal shoreline and tidal shoreline. When we started really delving into living shoreline and stream restoration work, we really thought the action was in the Gulf Coast in the Southeast United States. But more money is spent on coastal restoration in California than any region in the United States. So this really kind of brought home the enormity of coastal resiliency and the need for us to really look at some long-term strategies. Really, what is coastal resiliency? And I've got to give credit to two organizations, the Nature Conservancy and NOAA, who have really helped define what coastal resiliency is. And really, it is what it is. It's just how do you develop your community and how do you manage your community and how do you bounce back from events. What's interesting, I have some people that always tell me, well, why do we have to worry about coastal resiliency, and the political climate is such that, we're not really talking about global warming anymore. Washington, D.C., for whatever it is, the reason, trying to take it out of the daily discussion. But I tell people, well, we may not be talking about it from a political standpoint, but I can guarantee you everybody that's living along the coastline and is managing that resource may not be talking about what the causes of global warming or sea level rise is, but they're dealing with it every day. So we've kind of gone past that discussion, and you guys that are out there in the field clearly know what sea level rise is and are having to deal with it every day. But I recommend that you look at the Nature Conservancy's Coastal Resiliency site as well as NOAA's Resiliency site, and it goes in great depths of helping to guide you through what that process is. Now, how many of you out there have kind of entered into that process? I know some communities in North Carolina have, and in the Southeast. So you got to ask yourself, is that something that you guys need to do? Now, I know coastal resiliency may not be an easy discussion in the community. You've got a lot of competing interests. You've got, the political, you have to have the political will. You're dealing with tax bases. You're dealing with home ownership. You're dealing with, I spent $500,000 on a house to see the ocean. I don't want a dune put in front of me. So I understand a lot of the discussions and the political pressures that are out there, but I think we have to have these discussions. And when you look at this coastal resiliency concept, and really it's one of adaptability. I don't know many of you that think you can design your way out of a hurricane hitting the East Coast, or what do they call it, the Pineapple Express that comes in out of the Pacific onto the West Coast. And we're seeing more and more damage from storms that typically never really bothered the shoreline. nor'easters on the East Coast are now in some cases more damaging than small hurricanes. So let's look at hurricanes here in the United States this past year. We've had, Emily, we've had Harvey, Irma, Marcia, Nate. They all hit the coast of the United States in various areas. Matthew and Hermine back in 2016. Here in the Southeast, Matthew was a pretty significant hurricane for us. And another statistics I want to pull out and to kind of help you grasp the enormity. NOAA and kind of looks at the 33-foot elevation or the 10-meter elevation. And the United States has the third highest population in the world living below 10 meters, 33 feet. So we really are a coastal-based community, and it becomes more and more popular. So what makes coastlines more resilient? Well, obviously, our main strategy now is beach restoration and building beaches and building dune lines, which is an extremely expensive proposition. And in some cases, there's been a fair amount of documentation out there now that shows that beach restoration in some cases leaves you even more exposed to some of the lesser storms that come along the East Coast by overall steepening the beach front, removing, kind of the protective longshore sandbars, which are now our sources for sand, and building dunes in this great, beautiful straight line along beaches. So this is what you typically see down in the Southeast United States. Not at all unusual to see a shoreline that's like that, as you see in this slide, very exposed to even some of the more minor storms. Now let's talk a little bit about, this presentation is about compost or organics, and so let's do a quick look at organics. It is just what it is. It's basically recycled and composted green waste, creating different types of media, such as mulches, growing media, growing compost, and we all know the principles behind that and the value of that material. It really has a lot of biofiltration capability. It's very good at trapping sediment because of its varying pore space. Certainly its chemical properties have some cleansing capabilities. And certainly the biological nature of organics, the mycorrhizome, the bacteria all have beneficial uses in our environment. And that's where really Filtrexx takes advantage of harnessing that and delivering those types of qualities into the landscape. And really it's about as close as you can get to, getting yourself back to a forested condition without the trees. When you look at a forested condition, you have, a very heavy duff layer, you get great infiltration, you get slowed evaporation, you get dispersion of energy, and it provides optimal plant growth. And really, where can't you lose in compost? It's taking organics out of our waste stream, and we're beneficially reusing those in these natural systems. And we're going to talk a little bit about the carbon footprint piece with organics towards the end. So Filtrexx really works in the two arenas when it comes to the organic side. The filter media you see on the left is predominantly what we use in our Filtrexx silt fence replacement products, our EnviroSock, which we use for pollution abatement in some industrial post-construction applications, and our growing media, which is what we'll focus on here, which can be used in bioretention, can be used and compost blankets, and we will also place this in some of our mesh, and we use those in living shoreline situations, stream restoration. So we'll be talking mainly on the right side, growing media. I always show this slide because it really helps us understand the importance of organics and organic layers in the natural environment. So what compost does is get us as close to getting back to those beneficial conditions that we're all used to. Compost has, this is the US EPA compost blanket specifications. Another organization that has really great information about compost quality is the US Composting Council. So the lesson here is not all compost is compost. And if you are working in projects where compost is being utilized, two great resources, US EPA and US Composting Council, can help you understand what qualities you're looking for, and better yet, US Composting Council has some seals of approval based on certain parameters that will assure you quality. So great resource for you out there in the community. Now, when I said about Filtrexx, the great thing about Filtrexx is we originally sat down and talked about just around the table, how can we begin to use a lot of this compost, and how can we adapt it to the landscape. And on the left side, you can see a whole lot of erosion and sediment control practices that we have details for, that you all have access through the internet. You see stream restoration, living shorelines. We're very new to that marketplace. It wasn't an area that we were looking to get into, but through the creativity of a lot of people, we ended up working in that arena. And on the right, you can see a lot of our low impact development practices. And there's a lot of crossover between the two. But once again, all utilizing organic material. We'll talk a little bit about, what is sustainability. We worked on several projects, and I'm going to show you couple slides of a project where basically it took a bunch of those different practices that we developed on a lead building project, and created a small sustainable site where various practices were used for us to be able to try to naturally handle stormwater in a more natural way, where we were able to retain much of it on the site, re-infiltrate it back in the subsurface area, and it became less of a runoff issue. It's the site that we worked on back in 2009, where you can see various practices, green roofs, bioretention facilities. You can see this one facility where it was basically a dry stream bed with an expanded bioretention area. And what the objective there was to try to capture as close to 100% of the water as we can and create a zero discharge site. And we were able to, the engineer was able to do that by utilizing these low impact development techniques. And each one of these practices on here are using organics as the backbone of the project and the practice. This is where it looks pretty much today as it began to mature in. And bioretention has really become a mainstream practice in development, and we hope to see more and more of that. Same with green roofs. Here's some generalized practices where organics are being used. Slope stabilization. We do a tremendous amount of slope stabilization with organics. Large bioretention swells within developments. And yes, we've done some green roof work using some of our organics. That's just kind of a little taste of how organics are being used every day in projects. You know, compost blankets or compost has some great qualities in maintaining and reducing sediments, reducing nitrogen and phosphorus. And we always get asked the question, well, with organics, you've got nitrogen and phosphorus in the organics. What about that leaching out of there? And you got to remember, organic nitrogen and phosphorus in the environment tend to be bound up more for long-term storage within the soil. It's when you create that imbalance that it becomes a greater issue. And I always tell people, why aren't you using 100% organic lawn care service? And it's because it doesn't green up as fast. You don't see the instantaneous satisfaction that we as people like to see. So we still use synthetic or more readily available organics. So we're not going to tell you that there isn't some movement of nitrogen and phosphorus within, you know, the environment when using compost. But when we combine those with the vegetative establishment or the plant establishment, most of those nutrients get tied up within the soil matrix in the environment, so it doesn't become readily available for discharge. Our filter sock, the organics have some really great qualities to it. I always ask people, why are you still using silt fence when all the research shows that at best it's 40% effective in the environment? Why aren't you using more higher performing products? Filtrexx possibly being one of them, and one of those being total suspended solids. We've got a tremendous body of independent research that shows performance in the 80+ percentile. So, you know, it has some great qualities there. And this is oftentimes where it's used, you know, more in a construction area. We sell a tremendous amount of this material for silt fence replacement and slope interruption. And check dams and inlet protection. So I challenge you to go and look at some of those opportunities at a later date. We're able to really compost has a great deal of an ability to deal with turbidity. NTU, turbidity is huge. I remember as a regulator, we would always get calls. My stream is, or my river's filling in because the water's cloudy, and you get into the discussion, well, just because it's cloudy doesn't necessarily mean it's filling in, and you get into the total suspended solids in the turbidity world, but you still have to react to the public, and high turbid waters certainly has its own issues to deal with. Rainfall absorption, when you look at, you know, bare soils and you look at our traditional ways of stabilizing construction sites using straw mulches versus compost blankets, compost having the great ability to absorb large amounts of water within the matrix, we can get much less runoff during construction when we use and leave more organics on our job sites. Now we're going to start kind of getting into the meat of the discussion, and that's really, well, then how do you take organics and how do you begin to apply them to more land-water interfaces? And through my career, you know, I worked on stream restorations projects where we went whole hog with Roskin methods. Great method. Not sure how applicable it is down into the coastal plain. And I'm not sure we want to try to create streams, but really what David Roskin did was really elevate the science of how do you look at a stream? How do you try to determine what that stream is supposed to look like? And great value in beginning to look at how to make that stream functional again. So as I said, when we started getting more and more calls from people looking to us to come up with some solutions for living shorelines, and I use the term living shorelines as anywhere where water and land interface. So it can be in a coastal environment, it could be way up in the watershed on a stream. We started looking at projects that we've done through the years, and lo and behold, we've done a lot of projects that really qualify as living shorelines. So we did kind of a collection, and we developed a series of project profiles, which are available through our website, where it gets very much in depth into what those projects were and how we went about it. I'm going to go into some of these very briefly here in a few. So you'll have an opportunity to get access to those online. Then we started looking, holy moly, no, how do we begin to advance some of this? So we sat down and started sketching things. What about marsh edge protection? We worked on a project up in New Jersey where they're doing marsh restoration, and they were looking for ways to hold the dredged material in very shallow lift while they're bringing the material in, and lo and behold, we developed a solution for them. Dune restorations, we did a neat dune project up in New England. We've experimented in some dune scarp protection, and we've been doing a lot of work on bank stabilization along large and small stream and river systems. So, you know, we're not CAD operators, we're not designers by any stretch of the imagination, but we've kind of developed a couple concepts. And I repeat, these are concepts that we imagine that I throw out there for you as ways of maybe rethinking or possible areas where we may be able to work together on small projects to kind of refine these types of techniques. We also have a website, Living Shorelines, where we've kind of consolidated all this information, and that is available to you also on the website. And if I remember, I don't know whether you link through Filtrexx.com or whether it's a totally separate website, but that is out there for you to look. Now, one of the areas we're really interested in, and we've worked a little bit in, is dunes. And I was down in Myrtle Beach a couple weeks ago, and I was walking down the beach, and this was a newly created dune line. And I stopped some guy from the county who was driving his truck down the beach and asked him, "Are these really the finished project?" And he says, "Well, no, they're not finished yet. We just have to plant beach grasses." And I was looking at these things and thinking, now, how are these going to work? You can see it was high tide earlier that day, and we were almost right up to the dune line. And on the right side, further up the coast, this is in an island called Core Outer Banks, where Cape Lookout Lighthouse is. I go fishing there a lot on the beach, and there's their dune complex. Now, that's not a developed island like you have further along the Outer Banks and down into the islands of South Carolina and Georgia. But when you try to look at what we're creating on the left side and what we see naturally on the right side, you got to wonder, are we really creating a resilient shoreline? And if the political will is to do on the left, then how can we help maybe make those dunes a little bit more resilient for you? And I'm going to go into a project that we did up in New England, and I've got two photographs here for you. One on the left was during construction, and basically what we did is we built a core of a sand dune out of organic material. That's our mesh with organic growing media inside. Now, we were kind of just kind of winging it, and we used a little bit of a geogrid to wrap that whole pyramid stack, and then we covered that with sand, and we planted vegetation into it. And what we were able to find is, because we added that organics into that dune system, that we really got rapid growth in the vegetation, and we got much deeper root penetration of that root system within in that core. So what we felt is we made a more stable dune much quicker than what you would normally do by just piling sand. Now on the right, along came Sandy, so to speak, and you can see a view down the shoreline of what that dune that we built looked like after Hurricane Sandy. And basically what happened is we lost the sand definitely on the face. We lost some of the sand on the back, but much of the core remained in place. So even during the height of the storm, we still had a more resilient beachhead during the storm. And if you can look behind that picture to the right, you can see very little damage to the more upland area of the beachfront. So that was really a awakening for us. Now, I'm going to address the 1,000-pound gorilla in the room. And yes, that mesh is polypropylene. Yes, it is plastic. But even with Hurricane Sandy, we didn't see hardly any of the plastic get displaced such that it became free-floating into the environment. And in this case, all they needed to do was recover the core, replant the dune, and we moved forward. And that's what I think coastal resiliency is. Now, I'm not claiming that all these concepts or designs will survive hurricanes, but imagine the damage that you see in the southeast United States from nor'easters today. Could we make a more resilient system that would stand up to that and will save millions of dollars of having to come in and do a beach restoration a year later after we just spent $20 million to do beach restoration? So that's really what we're trying to do here with this slide presentation. We also did a little bit of kind of self-experimenting with scarp protection. Remember that dune that I showed there in Myrtle Beach that hadn't been planted, but the tide was almost right up to the toe of it. Imagine, that tide getting to that toe, twice a day, and how we will begin to nibble away at that dune system, even during larger tidal events, king tides, for instance. So up in the upper left-hand corner, I'm back on that same island core outer bank, and I started looking at some of the escarpment issues on some of these sand dunes, and you can see a sand dune up there that is still fairly stable. You still see great root mat, you still see great vegetation, but we're beginning to eat away at that dune. So we did a project where instead of creating a core, we basically placed a compost sock at the toe, and what we found out that we were able to build more sand along the toe of where we had the protection than where we didn't have protection on either end. So what we actually had to do is go back and reestablish a new sock, because the first sock had been buried deeper into the beach, so we could go in and replace another one. So what that really began to tell us is, even if we don't have the dollars and cents to do these bigger projects, maybe we can go in and do these smaller projects and get more resiliency out of the structures that we build, because we're not going to be able to build the type of dune systems that my previous slide showed. Here's a shoreline project that we did up in Virginia. And back in the old days, we would go, it was an undercut. We had fairly good vegetation in front of it, but we had an undercut in the slope. Back in the old days, we would just go cut all the trees down, come in with a little excavator, pull the slope back to a beautiful 3-to-1. And, we would maybe put a little matting on it, throw some seed, and call it good and walk out of there. But what we really did then is we really altered that shoreline even beyond what Mother Nature has kind of created this equilibrium. So as you can see, we went in and we tucked compost-based filter socks that were seeded into that undercut. We used grids in this case because we had a fairly decent fetch here and a lot of boat traffic, so we wanted to create a little bit more of a resiliency practice. We didn't cut any trees. You can see the tree still sitting to the right, and you can see in the fall that same project over on the right. It has become very naturalized, and we didn't have to do a lot of alteration to the landscape in order to make that happen. So another way of using organics in a restoration type project. Also, our compost filter socks are used a lot in more traditional sand placement, living shoreline projects where we run them parallel along the shoreline to keep the shoreline stabilized so the vegetation can get established. And in many cases, we'll go back in and remove the mesh and just leave the organics on the beach, and we can move on. It's a neat project that we were asked to do, another resiliency project. Virginia DOT was spending a tremendous amount of dollars and cents in having to keep a channel open that was draining a low-lying road area. And they just got tired of having to go in there and get permits to continually reestablish this drainage system. So they asked us to come up with a solution. So you can see we have compost-based filter socks, or socks on the side, and they were planted with native vegetation and directly into the organics. And what they were able to do is really reduce their long-term maintenance costs in trying to keep this channel. And the road was not being affected as much by both tidal influences and rainfall events because we were able to create a more natural, free-flowing outlet system. So these are all different practices that we've kind of worked on, and we've got a heck of a lot more that we can get into. But I really want this to be your time to ask us your thoughts and give us ideas about practices or projects that you may have or we may be able to help you. Because I can tell you one thing about Filtrexx is if you need us, we're there to help you come up with solutions to help solve your long-term problems. And a kind of an advancement, I mentioned carbon sequestration. We did a little bit of kind of research in the literature, and on the left side, you can see we have a technical link that can now, with using compost-based BMPs, you can look at several aspects such as CO2e methane avoidance, what kind of CO2 response you'll have in the sequestration of the soil and the vegetation. Also, we can determine the amount of organics that had been taken out of our waste stream and utilized on this project. So we have that available to you and can provide that on any one of your projects. Because we're hearing more and more about the need for us to be more carbon neutral as we can in a lot of our projects. So we have the ability to help you. And on the left side, you see a living wall that we did on a lakefront up in Wisconsin, and you can kind of see some of the amazing numbers of organics avoidance and rainfall absorption. And we can even go a little step further that if you're looking for kind of third-party verification that these practices are meeting kind of your sustainability requirements for projects. We've teamed up with a organization out in Des Moines, Iowa, and we can incorporate them into the project. And what they are is a third-party, unbiased verification process for you to be able to determine what those eco-practice benefits of that project are. Because I don't necessarily, carbon trading was supposed to be the next big thing. I almost see carbon trading or carbon sequestration as a way for us to almost replicate how we deal with tree removal. If you can't replant the trees, we can provide, in exchange for dollars, we can provide, ecosystem benefits on the back end by taking those dollars and reinvesting those into your watershed, bringing in some of these more high performing eco benefit strategies. So that's kind of the presentation as we wanted to present to you. We really wanted to try to create an interest in the concept of coastal resiliency and how organics could possibly be a tool in your toolbox when you begin to look at how do we deal with that coastal interface and how do we deal with water as it moves through the landscape down to our coastal environments. We will be the first one to say that there is never one single practice that is best. It really is a comprehensive approach, and it really is a comprehensive use of different technologies. And I think that's what that coastal resiliency concept and planning technique is really about, is a way for you to go and look and identify those opportunities for you in your long-term management of your coastal resources. So with that, I open up to questions, and I'll make one last plug here. We wrote a book, and it's sold by Forrester Press, called The Sustainable Site. And really what it is a book that takes our various designs that we've developed through the years and put it in a context of low impact development and green infrastructure. And once again, it's another resource that you can get and a very valuable resource that you can read to help you wrap your mind around what coastal resiliency is and what green infrastructure and low impact development is. And we don't necessarily say we're the experts in the field by any means, but we feel we have a value there for you in your quest to deal with those community issues. So with that, I open it up for questions. Kristen, how do you want to handle the questions?
Sure. Yeah, we like Jeff mentioned, we have time for questions here. So if anyone has a question, you can type that into your dashboard, and we'll pitch those over to Jeff. It should be right in your dashboard there, the questions panel. You can just type that out. And also to mention quick, the design manual, the Filtrexx branded version, is available on our website as well for all PDF and CAD downloads as well. If you're looking for a digital copy of that also. So we can give it a couple minutes here. Jeff, is there anything you want to cover back on? Okay, here's actually one that just came through from Andy. Do you have projects where you have where you halo stabilize shorelines along earthen dams? You have
Yeah, we do. We actually completed a project in Charlotte. We created a project much like that in South Carolina just recently. Our green lock system really is kind of the backbone of these shoreline or stream restoration techniques, and it's very adaptable to the situation. So yeah, we do have some projects, and I would be happy to, if you want to contact me, via my email at jopel@filtrexx.com or my phone number there. I'm more than happy to get project specific with you, and more importantly, I'm a very visual type person, and if you have photographs that you can provide us, we can certainly help you better. And I do have salespeople around the United States and a good concentration in the Southeast. We're always looking for an opportunity to go out into the field and look at issues and help with solutions. So yes, we've done a fair number of those types of projects along faces of dams.
Great. Okay, we have a question from Marilyn. What monitoring activities do you do, and can you share data on specific metrics like wave attenuation and biological values other than plants?
All right, great question. We can provide documentation as to the shear forces that our meshes and our products can withstand. We've not done any long-term or any studies where we've looked at that as a research project, although there is a research project going on in Virginia with some grad students where they have taken our material and placed it along beach fronts, and they're looking at that type of information about what shear forces it can stand, and they're also looking at sand accretion rates by utilizing that product. So to provide you that exactly what you're looking for, no, I don't have anything for you. And as far as the ecological benefits, we can provide you a lot of ecological benefits of the media itself as it relates to the organics.
Okay.
I hope that addressed your questions.
Mm-hmm. All right, another couple questions coming through here. Have you constructed any projects on the West Coast?
That's where I'm heading west. As I mentioned, we really were focusing on the Southeast United States and Florida and the Gulf Coast. But when I was preparing for this presentation and saw the amount of shoreline out on the West Coast, I had one of those aha moments. So I will be out at a technical exchange with the U.S. With the estuaries, with an estuaries organization out in LA in February. We are going to go out and start working and looking for opportunities out there. We have worked with a couple solutions over in Hawaii and have come up with some concepts for them. But having set projects on the ground along the coastline in California, we have not. So call me. I would love to work with you.
Perfect. Okay. Are the state and federal dam regulation agencies receptive to these strategies relative to their standard hard armor rock face?
Yeah. Here's kind of an interesting thing. Our systems are in both the USDA field manual, Army Corps of Engineers design manual, US EPA manual. So they are practices that are accepted within their manual. We have not been rejected on any project by any dam safety organization yet as to the material being placed versus hard armoring. But you got to understand, much like our Filtrexx silt sock, which has been in the market for 15 years, it's very difficult sometimes to change tradition and the way that we've always done it. So we will work case by case on that if you have any particular projects available. And we will also combine our systems with hard armoring systems. We do have a design where we work with McAferry, where they have used McAferry systems, gabion baskets along water faces, and we've provided a green face in those gabion baskets. We're working on a project with Alabama Power, where we're basically going to be working off the top of a more structural stabilization practice that is going to be dealing mainly with shipping traffic wave action, but we will handle the flooding elevations within the river system above that. So we're often used in conjunction with other more hard armoring opportunities to lessen the impact of the hard armoring.
Great. Okay. Those are all of the questions we have lined up for now. Again, I will be emailing out the certificates of attendance, and I will also include Jeff's contact information so you have that handy in case you have any questions that come up or projects you'd like to discuss. And those will be emailed out by Friday to the email address that you registered with. And also you can, again, visit our website, filtrexx.com/webinars. We have a few more, I think 2 more topics scheduled for the rest of the year, and then we'll be having next year's schedule posted soon, and I'm sure we'll have another session like this one as well. If you have any colleagues that might be interested, you can definitely pass that on to them. Jeff, do you have anything else to add before we close out?
Yeah, look, we really appreciate the opportunity that you've provided us of your time, and we really look forward to the opportunity to work with you guys. We will be very upfront whether we think we can help or not, but we are really looking for people who want to try some of these newer concepts that we've come up with and try to better understand these systems. So if any of you have access to the Sea Grant University system that contacts there, or the graduate system network, we would love the opportunity to help better understand and advance. And last but not least, one of the most exciting things in today's marketplace is the exploration and the development of compostable and biodegradable plastics, so to speak. Filtrexx is proud to be part of a global organization, a company called SWM, and they are the world leaders in the development of new and emerging technology. So stand by. I think you're going to see some pretty exciting things happen within the next year or two when it comes to some of our meshes. So with that, I appreciate it, and I wish everybody a great remainder of your holiday season. Thank you.
Thanks, Jeff. Thanks, everyone. Have a great week.